Welcome to the video lecture. In this video, we are going to find the ROC curve for the given binary classification problem. So before moving on to the problem, I first explain what is confusion matrix and how we are constructing the ROC curve using that confusion matrix. And this is a confusion matrix and you have to plot against actual predicted label against the actual label. So the predicted values and the actual values are plotted against each other to find the true positive, false negative and true negative case. While the actual value is positive and we are also predicting the value is positive, then it comes under true positive. But the actual value is negative, but we are predicting it as positive, then it comes under false positive. Whether the actual value is positive and we are predicting it as negative, then it comes under false negative, and the actual value is negative and we are also predicting the value is negative, then it is coming under true negative. This is the confusion matrix, and based on the value of these confusion matrix, we are going to find the true positive rate and the false positive rate to construct the ROC curve. This is the ROC curve we are going to construct based on the values of true positive rate and false positive rate. This false positive rate is actually plotted again in the x-axis, and the true positive rates will be plotted again in the y-axis. And AUC is nothing but area under the curve, area under the ROC curve. So in this video, we are going to find this ROC curve based on the given labels. So the given problem is a binary classification problem. We are going to predict whether an email is spam or not spam, whether it is positive or negative, whether it is 0 or 1. We are going to find the ROC for this classification problem. So let us consider the label as 10, 10, 11, 00, 10. These are the true labels and these are the respective probabilities predicted for these true labels. So here we are going to take a threshold value to predict the new label. So we are considering 5 threshold values, 5 different threshold values. The threshold values can be randomly chosen, so that you are using that threshold value to predict the new label. So for the case 1, the threshold value is considered as 0.5. First, we have to list the true labels which is given in the problem, and we have to list the predicted probabilities for the respective labels. So now in this column, the third column, we are going to predict the labels based on the threshold value. So here we have to compare this predicted probability with the threshold value. So if this predicted probability is greater than the threshold value, then the predicted label should be 1. If it is less than the threshold value, then the predicted label should be 0. So here it is greater than the threshold value and it is less than, here greater than. This is also greater than 0.5 and this is less than 0.5. This is also less than 0.5. This is greater than 0.5 and this is also greater than 0.5. So for greater than the threshold value, the label should be 1, and for the less than the threshold value, the label should be 0. This is how we are predicting the labels. So based on these predictions, we are going to construct the confusion matrix we have discussed previously in this video. So this confusion matrix, we are going to plot the actual values against the predicted values. So actual 0, actual 1, predicted 0, predicted 1. So the value which is coming here should satisfy the condition. The actual value should be 0 and the predicted value should also be 0. So here checking the condition, here the actual value is 0 and prediction is also 0. Here is this row is also satisfies the condition, and this one is also satisfying, this one is also satisfying. Here the actual is 0 but the prediction is 1. So the value, true positive value is 4. So here the actual should be 0 and the prediction should be 1. So this one satisfies this condition. So the false negative value is 1. So here actual 1 and prediction is 0. So here actual 1 but it is also predicted as 1. So this not satisfies the condition. This one is also not satisfying. And so there are no values in the false positive, and actual 1 and also predicted as 1. Here there are 5 cases. So 1, 2, 3, 4 and 5 cases. So the actual value is 1 and is also predicted as 1. So there are true negative value is 5. So based on these values, you are going to find the true positive rate and the false positive rate. True positive rate is nothing but a proportion of actual positives correctly identified by the classifier, which is calculated using the formula true positive divided by true positive plus false negative. And the false positive rate is the proportion of actual negatives incorrectly classified as positive. So false positive divided by false positive plus true negative. So based on the values present in the confusion matrix, the calculated TPR value is 0.8 and FPR value is 0. So likewise, for case 2, considering the threshold as 0.7, we are predicting the labels. Here the predicted probability is greater than the threshold value. Here it is less than, less than, less than. In this case it is equal to the threshold value. So in here also it should be 0, which is not greater than the threshold value. So it should be 0, and here it is greater than the threshold value. It is less than, greater than and less than. So for greater than the threshold value it is 1. For less than the threshold value the label should become 0. So these are the predicted labels, and the confusion matrix and the true positive rate and false positive rate can be calculated respectively. So actual 0 and predicted 0, 1, 2, 3, 4 and 5 values, and actual 0 but predicted as 1, there are no values, so it should become 0. And actual 1 and prediction 0, actual 1 but predicted as 0, 1 and 2. So there are 2 values. Actual 1 and predicted as 1. So actual 1 and also predicted as 1, 2 and 3. So there are 3 values comes under true negative. So based on the values in this confusion matrix, TPR and FPR can be calculated. So for case 3, threshold value is taken as 0.4, which is greater than threshold and less than threshold. So here it is greater than, less than, greater than, which is equal to, which is not greater than, and which is less than, greater than, and here is also greater than. So for greater than values it will becomes 1, and for less than and equal to values it will become 0. The predicted value becomes 0, and the confusion matrix based on this is actual 0 and prediction 0, 1, 2, 3, 4. So there is 4, and actual 0 but predicted as 1 is 1 case. So here false negative becomes 1. Actual 1 and predicted as 0. So here there is no values coming under this condition, so it becomes 0. And actual 1 and predicted as 1, 1, 2, 3, 4 and 5. There are 5 cases coming under true negative. So the true positive rate and the false positive rate can be calculated from the confusion matrix, which is 0.8 and 0. So for case 4, threshold is taken as 0.2, which is greater than threshold, greater than threshold, greater than, which is equal to, which is not greater than, and here greater than, less than, greater than and greater than. So the respective labels are predicted, and the confusion matrix can be calculated from the labels, predicted and actual labels, and the true positive rates can be calculated using the values found here. So for case 5, the threshold value is taken as 0.85. So here it is less than, here it is only greater than, less than, and less than. So other than 0.9, all other predicted label becomes 0. So the confusion matrix can be calculated from the values, and the TPR and FPR values can also be calculated. So far we have calculated for 5 cases, 5 different threshold values. We have calculated the TPR and FPR. So we have to plot the TPR against the FPR so that we can construct the ROC curve. So based on these values, 5 different threshold values, the TPR and FPR values have been calculated, and the ROC curve has been constructed. This is the ROC curve, and I am plotting the true positive rate here and false positive rate here. So your false positive rate always occupy the x-axis, and the true positive rate always occupy your y-axis. So here in the case 1, the true positive rate is 0.8 and the false positive rate is 0. So for case 1, this is for case 1, this is the point for case 1. And for case 2, true positive rate is 1 and false positive rate is 0.2, and this is for case 2. And for case 3, which is also 0.8 and 0, so case 3 is again the point comes here. And for case 4, true positive is 0.4 and the false positive is 0. So this is for case 4. And for case 5, true positive is 1 and the false positive is 0.8. So for case 5, your point should come here. So based on these points, I have constructed the ROC curve. So the ROC curve constructed for the given set of true labels is shown here. So this is the way of finding the ROC curve for the given set of labels for the binary classification problem. So thank you for watching the video.